talk about STM32 CubeIDE software. So I will give you a brief intro of this software, and also we are going to do a little project of toggling LED. Let's start with. You just need to go to the website of STM32. There you can download your required CubeIDE software. Then after downloading you will see this picture. You can go to the file, new, and STM32 projects. It will take few seconds to initialize STM32, and now they have all the STM32 ICs. So here you can have four different things. First is microcontroller unit selector. Here you can write their part number, or you can also identify that which type of microcontroller you need. The selecting criteria for this microcontroller unit is very variable. So you can also identify which type of STM32 you need: low power MCU, wireless or high performance MCU, or which series you want specifically. And also you can have how much flash memory you needed. If you need it a bit less, the options will be less, and if you need a bit more higher number of amount in flash, you can also get. So they gave you a big range and variety of selection for this microcontroller unit. You can play with it as much as you want. Do they have USB interface? How many USB interfaces they should have? And graphics, which type of graphics they could have, like how many interfaces they could have. Moreover, like there are bundles of options by which you can categorize this specific microcontroller unit. So this is really helpful for your projects. So this is only one thing. Second is the board selector. In board selectors, you can see here, I can make it a bit bigger. These are the boards with little information. If you will click on any board, they will give you this intro here, like their price, their name, what are they required for. Let's select any other one. If you need this one, this is Cellular IoT Discovery Kit powered by STM32L4 and STM4 SIM. And here if it is written active, active mean they are also producing it, and it is possible that if you will order you can get it. And maybe if there is something is written non-active or something, then obviously it means that you cannot get that, you have to find another one. So this is the proper specification of selecting your required IC or board, or here you can also find example selectors which are provided here. Obviously because it is a bit heavy software, it takes few seconds. So if you will go with example selector, you can find this board, vendor, here, which IC this board is using. So if you are going with this one, so this one is having the size of the IC, and this IC is attached on this board. This is the name of the board, multi-sensor ranging, something like this. So here you have a big numbers of ICs or boards which you can select. Okay, so for this one I will just use a random, I have something in my mind, I can use that IC. You can write here STM32. Normally I go for F series. Today I will go with maybe G series, G071, 72, anything, maybe RB. So now we have a lot of options here. You can go with anyone because the blinking LED can work with any IC or board, you can say, because it's just a very simple project. So I will go with T6. You can take anyone, not much difference. The bit difference which is here, you can read it here. So I will go with this package. Both are almost same for me. So go to the next. Here you can write the name of your project. As I am using the G071, so I am keeping it a name of G0. Let me write in capital G071. Maybe I can just write something blinking, blink LED. Okay, I think so this project is okay for me. I just remove the space. It will be in C language, executable, STM32 cube, fine, very good, go for finish. Now the thing is, it will take few seconds to load all the required software and the required, how I can say, the components for that specific IC. It will take few seconds. Um, let's see. Yeah, now we have this IC here. You can also zoom in, and here you can see all the different peripherals or the input output pins. What are these, all these pins? You can find it here. This is the brief intro for your IC. Here, let's see, just take an example. I will go with sys. Let's go to the sys. I just want to use the serial wire, and when I will click here, you can see something change here. See, here as I clicked here, then these two pins get a bit green, and if you will click on them, so they got this thing that for communication, for serial wire communication, I'm going to use PA14 and PA13. And you can click on this, left click on this, then you can have all these things. It means if I am not selecting it for serial wire, I can use this specific pin for all these functions, but I think so once at a time. So right now it is green, it is going to be used for 6 clock and for the serial wire communication, and this is for the same thing. If you will click on, like, left click on any of these, all these pins can perform these functions. Okay, if I will left click on this one, it will not show you any numbers or any specific functions, because this pin already dedicated and configured for this power button. Same for this one, same for all these three in yellow color. Okay, next is, I know that I am going to do the serial wire communication through these two pins, and I have to put a LED. Normally we can, there is also a schematic on the back end where it is shown that the LED will be connected with on PA6, sorry, PA5. So if you cannot see where is PA5, you can just write here PA. All the PA pins will blink here, and if you are searching for PB, just write here PB, and all the PB numbers will blink here. At the same time, if you will click here VDD, let's see, that pin will click here. So you don't need to search and zoom it and find it, like which pin you need. Their numbers are there. If you will go with PC, these pins will blink. So this is the very handy thing which you can use here. We need just PA5, it will blink, just select it. It will continue blinking until you do not specify it for some specific task. Basically, we are going to use it for GPIO output, because output means we are giving it a signal for the LED that it should blink with a specific command. Okay, At the same time, you can also left click and it will help us later in the programming. So we can just give it a name of LED lower bar and blink or something like green. Okay, enter. Now we gave it a name of LED green. We can use this name or this label in our programming in future in the same project. Okay, a bit more explanation about this IC. If you want to understand more about this IC, you can click any of these. It will appear here. Then you can click on them. Just let me click here, TM1, double click, and here all the things will appear. If you wanted to enable or activate anything, it will show here precisely. And which type of connectivity this IC can have, you can just go here. So this IC can be connected in USART, UCD, PD, SPI, I2C. Lot of connectivity possibilities are there. Moreover, after giving its LED pin number and the serial wire, we will go, the second step you have to do is the clock configuration. It has given already this clock. So LSE mean like low signal external, high signal internal, high signal external, high signal internal, low signal internal. So it is automatically using high signal internal, which is 16 megahertz. So we are not going to change it because exactly we don't know how it is required, but in some projects it is specified that which amount of megahertz of frequency it should be required for the clock. In that way you can change it also by changing something from here or here, like it can come from the outside. This is the range from outside signal which you can use if you will enable it, 4 to 48 megahertz, which you have to like connect some oscillator on some pins where you can put the oscillator and you can get this range of frequency for your circuit. Project manager, just your name which you already give here, tools. Okay, now the second thing is we are going to write the program. Let's see, go here to the core, then this is the source, then go to the main C, double click here, and here the main program will be written here. So where you are going to write your command to control the IC blinking. Let's go to the while here, and I will show you. If you will write here and write here, what will be the possibilities of having error. Let's see. So it will always start with, as you can see here, HAL, then underscore, then what do you know that which program we are going to write? We are going to write for GPIO, general purpose input output pins. So write GPIO. And if you don't know that what will be the functions this GPIO can do, then you should press Control space. It will give you all the functions which general purpose input output pins can do. So for toggling LED or for blinking LED, you can choose right pin or you can choose toggle pin. So this is very helpful function. You can just write HAL bar GPIO pins or anything else other than GPIO. Then it will shows you which function you needed. For us, I think so I will go with toggle pin, double click. Now in the toggle pin, it is having two commands. First command for the GPIO like the port, and second one for the GPIO pin. So here in this one we will write here, let's see. Now you remember that we give a name, label of our LED green. Here we will just write something LED underscore then GREEN. Then we can go for control space, and nothing will appear as we see because we did not save this file. If we did not save the file, then it will show a star like this here. So before we are finishing this thing, we have to save our file, then it will work properly. Now we will go with control and space. Anything in this program which is saved under LED green number or words, it will appear here. So right now, first one, as I told you, that was the port. So click on this one, double click on this one, then comes here. Here it is pin, again write LED underscore green, then again control space. Here second was the pin, double click here, semicolon. Now we want that when LED blink, it should have some delay in it. So the same function where we use in every code here, we can write here hall underscore something like delay. Just write anything for delay, it will appear. Then again do control space, it will give you the function. This is the function for delay. Double click here, and for this delay I am going to put only 500 millisecond, half second it means, and that's it. This is the whole thing, and semicolon here. This is the whole thing. If you will run this program in this software, it have to run without any problems. If the problems will appear, we can see it here. Let's minus it and then see the problems here. Even it is showing here what you are doing, but let's see. For building the project, you have to click here. It is the build debug for project. This is the name of the project, G071 blink ID. Click here, just leave the console, go for the problems, give it up. It is showing some problems, so let's put colon here and again build the project. Now it is not showing us any problem here. How we know that? Because what it is generating, it is showing this much text which is generated. This is the data which is like transferred, and this is the hex file, final hex file for the blinking LED. Till this point it is all okay, so I'm not connecting any external STM32 board or LED. This project is till this point for the software. So if this thing is coming here, this command is coming here, it means you connected the right thing here and you did the right profiling or the right coding for your IC. So till for this video, till this much is enough. And again you can see the static is not here because it is saved. So if you will do without saving this thing, then it will not show you your right commands. So enjoy this video, learn more. In next videos I will try to use some sensors and the motors by using this STM32 microcontroller. Subscribe, like and comment and share with others. Thank you so much.